So we have to talk about bonding because you're taking a quiz on it tomorrow, and there's going to be a bonding review that will have a bunch of practice problems for you. So I suggest that you play along and practice with me as we go through this. The first thing that we should remember is that ionic bonding is a situation where an atom gives an electron to another atom. It's where an atom that gives an electron will have 1 or 2 or 3 valence electrons. It'll be on the left side of the periodic table. It'll become more positive. These will be metals. So you want to remember that these will be metals. And then atoms that accept electrons are going to have 5, 6, or 7 valence electrons. They'll be on the right side of the periodic table, and they will become negative. These will be nonmetals. Okay, now, the attraction between the positive ion and the negative ion bonds the two atoms together. So remember, you have to draw the LDS for each atom and show which electrons will move to where, and then write the new Lewis dot structure in brackets with a charge, and we separate the charges from each other so the positives are not standing next to each other. Covalent bondings occur when two atoms share valence electrons. They're only nonmetals, so it's nonmetals. Oops. So it's nonmetals only. So we would draw a Lewis dot structure for each, circle the electrons to share, to show that sharing is occurring, and then rewrite the Lewis dot structure. There's no charges on covalently bonded atoms, and we make sure that all of them are surrounded by 8 valence electrons. The one exception would be hydrogen, which will have 2 valence electrons. So let's try a couple of these. First of all, we have CaS, which is calcium and sulfur, so I'm going to draw my structure. So because it was a metal and a nonmetal, this is going to be ionic. Okay, so that means that we're going to draw arrows and brackets. So let's start. So we know that we have calcium, and calcium we just looked up had 2 valence electrons, and sulfur we just looked up had 6 valence electrons. So now I'm going to draw an arrow to indicate that the electrons are being transferred. Okay, and so now I'm going to redraw my structure. So over here I'm going to have sulfur, which will have 1, 2, 3, 4, 5, 6, and it's going to have 7, 8 electrons that were transferred. And because it has gained 2 electrons, it's going to become -2. Calcium, on the other hand, has lost its 2 electrons, and so because it's lost 2 electrons, it's going to become a +2. So that's how that particular structure is going to work. Go to my periodic table, and I'm going to see that calcium is here and sulfur is here. Calcium is on the metal side, sulfur is on the non-metal side. I know that this is 1 valence electron, 2 valence electrons. We're going to skip these. 3 valence electrons, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons, and 8 valence electrons. So I know that sulfur has 6 and calcium has 2, so that will help me when I'm going to move on to the next one. Carbon dioxide, CO2. So I'm going to go look at my, can identify this to be covalent. Oops. It's covalent, which means they're sharing electrons. It means that they are, we're going to draw circles. Okay, so the first thing I'm going to draw is I'm going to draw my carbon, which I'm going to have 1, 2, 3, 4 valence electrons, because we figured that out before. I'm going to draw one of my oxygens, which will have 1, 2, 3, 4, 5, 6, and another oxygen, which would be 1, 2, 3, 4, 5, 6. Now I'm going to go ahead and look and say, well, I don't want to draw a circle around pairs because those guys are already paired up. So what I'm going to do is I'm going to draw a circle around single electrons and pair them up. So I'm going to do this, and I'm and I'm going to do this, and I'm going to do this. So now I've got a situation where oxygen has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, and carbon has 1, 2, 3, 4, 5, 6, 7, 8. So he has 8 valence electrons. And oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Also 8 valence electrons. So when I draw this structure to sort of, I guess, clean it up a little bit, I might draw it to look something like this. And indicate that there is a share there, and a share there, and a share there, and a share there. You could also draw it like this. That would be fine as well. Periodic table, and I'm going to see that I have a carbon, and I have an oxygen, and actually I've got 2 oxygens, so that's going to be 2 nonmetals, 3 nonmetals total. And I know that this has 4 valence electrons and this has 6 valence electrons, so I'm going to go. Okay, now next one is NABr, so I'm going to go look at metal. So that tells me it's ionic. It's a metal and a nonmetal, and that means they're going to be transferring electrons. And we should draw arrows. So first of all, I'm going to draw sodium, which has that 1 valence electron, and I'm going to draw bromine, which has 1, 2, 3, 4, 5, 6, 7 valence electrons. And because we need to show a transfer, I'm going to draw an arrow like that. So over here, I'm going to have bromine with 1, 2, 3, 4, 5, 6, 7, 8 electrons. Because it gained 1 electron, it becomes -1. And I'm going to draw sodium, Na, who's lost an electron, so it's going to have brackets around it, and it's going to be a +1. Okay, and those are the ones that we did in class. So periodic table, I'm going to find Na, which is in that first column, Br, which is in that 17th column. So this has got 1 valence electron. This has got 7 valence electrons. So it's metal. Keep pushing forward and do the rest of them. So we have PCl3. So I need to go look at this on the periodic. So that tells me it's covalent. It's nonmetals. They're sharing. So I'm going to have circles. So I'm going to draw my original structure for phosphorus, which hopefully will. So phosphorus will have 5. So I'm going to go 1, 2, 3, 4, 5. Chlorine, and I've got 3 of them. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now I'm going to go ahead and, because it's covalent, I'm going to draw circles, like one like that, and one like that, and one like that. Okay? So now I'm going to go ahead and kind of try to clean this guy up a little bit. So I'm going to have my phosphorus in the middle. I'm going to do 1, 2, 3, 4, 5, and I'm going to put my chlorine right here. 1, 2, 3, 4, 5, 6, 7. Another chlorine right here. 1, 2, 3, 4, 5, 6, 7. And another chlorine here. 1, 2, 3, 4, 5, 6, 7. And now what I'm going to do is I'm just going to show that they're circled so that they're sharing their electrons, something like that. Everybody's happy, and that's good. So we're going to move on to the table. I have P over here, and I have Cl here, here, and here. So basically, I've got 2 nonmetals. You can look and see that phosphorus has 5 valence electrons, and chlorine has 7 valence electrons. Okay. Okay. Now, K2O. Okay, so I'm going to go look at my period, and I'm going to identify that the potassium was on the metal side, so this is ionic. It's a metal and a nonmetal. electrons are transferred, and electrons are transferred, and arrows. So we have to show arrows. So my first structure I'm going to draw is potassium. So that's going to be K with 1, and we have 2 of them, so I might as well draw that right away so I don't have to change colors. Oxygen is going to be having 6 valence electrons, 2, 3, 4, 5, 6, and because they're transferring, I've got to show arrows here and here. So now I'm going to draw my oxygen. So oxygen of 1, 2, 3, 4, 5, 6, 7, 8. Okay? And because it gained 2 electrons, it's going to be a -2. Potassium is going to have lost an electron, so it's going to be a +1. And the other potassium is going to have lost an electron, so that's going to be a +1 as well. And that's drawn pretty well. So we're going to move on. Table. I'm going to see that potassium is in the first column and oxygen is in the second column. There's a second potassium. So this has 1 valence electron. This has 6 valence electrons. So I'm going to O3. Okay, so I'm going to go over here. I'm going to go check my periodic table. I'm going to say that it's going to be covalent because it's nonmetals only. Okay, we have shared electrons and circles. Okay, so I'm going to draw oxygen once. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And another one. 1, 2, 3, 4, 5, 6. And now I'm going to draw circles. So I'm going to do this guy here. And maybe this guy, let's see here. Here. And then I'm going to draw, what's the problem? That's O2. That doesn't make sense. So maybe we should go back and draw this. And maybe we can draw this. So I guess we could draw something that looks like that. That might make sense, I guess. So let's see. We can draw that and say oxygen, oxygen, oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. That's going to be something that looks like this. And we'll call that a day. That'll be fine. I'm going to note that oxygen and oxygen and oxygen. So I've got 3 oxygens, right? So I'm going to go back. Moving on. NH3. Okay, so draw our structures. This is going to be covalent. It's going to have nonmetals only. And it's going to be nonmetals covalent, and it's going to be circle. Sharing and circles. So I'm going to draw my nitrogen, which is nitrogen, which has 5, 2, 3, 4, 5. And my hydrogens each have 1. And then I'm going to draw my circles. Okay, so now I'm going to say nitrogen would have 1, 2, 3, 4, 5, and put a hydrogen here, and a hydrogen here, and a hydrogen here, and then I'm going to draw my circles, and that's going to be satisfied. We'll look at nitrogen here, and we've got 1, 2, 3, so this has 5 valence electrons and 1 valence electron, so we're going to go, and so now we need to go on and look at MgO. So we're going to go ahead back, and I'm going to identify that because they're a metal and a nonmetal, so that's ionic. Okay, metal and nonmetal. So there's going to be transfer electrons. And arrows. So I'm going to draw my magnesium. 1, 2. And my oxygen, which would be 1, 2, 3, 4, 5, 6. And then what I'm going to do is I'm going to show my transfer. So there's going to be a transfer here and a transfer here. And when I draw the oxygen again, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. and it's going to have a bracket and a gain 2, so it's going to be a -6. And then my magnesium is going to be Mg. It lost 2, so it's going to be a +2. Take a look. Magnesium, oxygen, 2 valence electrons, 6 valence electrons. So, all right, maybe one more. Ooh, this is a tough one. This is a tricky. Okay, so we're going to go back, and I'm going to draw. I'm going to say that this is ionic. It's metal and non-metal, and it is arrows and transfer of electrons. So I'm going to draw my 2 aluminums. So Al would be 1, 2, 3. Al would be 1, 2, 3, and oxygen would be 1, 2, 3, 4, 5, 6, and oxygen would be 1, 2, 3, 4, 5, 6, and oxygen would be 1, 2, 3, 4, 5, 6. Now I'm going to show my transfer. So this is going to be like an arrow here, and 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 an holy mackerel. So we have oxygen, which is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and each of them gained 2 electrons. So each of them is a -2. And then I've got my aluminums. Both lost 3 electrons, so they're going to be, whoa, what is that? Both of them lost 3 electrons, so they are going to be +3. And there you have it. And take a look at the periodic table. We've got our aluminum, which I'm going to tell you aluminum is a metal, and we got oxygen. Okay, so this is 3 valence electrons, and this is 6 valence electrons. So all is good. Good luck with your quiz tomorrow.